Welcome to the Center for Suicide Prevention and Recovery Spotlight research presentation. We are happy to have you all here to hear about the work that we've been doing as we have recently been coming to the end of our study of the use of Google search data as a potential predictor of suicide risk. I'm Kate Comtois. I'm the center director, and I will briefly introduce our team of from our Google study. I'll present the basics of the study first. Then Peyton Smythe, one of our research scientists, will tell you a little bit about what we've learned in terms of kind of how to conduct research like this. Then Kevin Saulnier from University of Michigan will be presenting on the results of our prospective surveys on our warning signs of suicide and how that relates to suicidal thoughts of behavior. And finally, Xingyang Ren will be presenting on the data we have so far on our Google search. And then following that, our distinguished guest, Pat Aryan, who started this project with me, will serve as a discussant and kind of reflect on what we've learned. So I will kick us off with just have to get myself to the start here. Here we go. All right. So I just want to say a special thank you to everybody who participated in the Searchlight study. We were a large team from CSPAR, our center here, the creative team, the biomedical informatics team, ITHS. Thank you again to Michelle Harvey for all of her work in REDCap, our team from University of Michigan, and from CAMH, who developed our Google app. And this grant was supported by the National Institute of Mental Health, but our comments are just our comments. So I sort of usually pick a suicide is bad slide. The thing that's been really striking me the most about suicide is the change in rates for us here in the United States and in North America compared to what we're seeing in other parts of the world. I think that we are living in this sort of constant sense of the numbers going up, although we did have this little dip there for a while. But it's important to note that that's not true everywhere in the world, and we need to be figuring out what's going on with us. And that means we need to get out of the box and start looking at things from different perspectives. And that's what we decided to do with this study. So what our study was designed to do was to reach 1,000 adults living in the United States with suicidal thoughts and behaviors. And you can see the different inclusion criteria as you move through our process. On the left, I'll say a little more about this process as we go, and then Peyton more on kind of what worked and what didn't and how we managed to get our patients through the process. We had a retrospective component. This was a baseline interview conducted on Zoom using gold standard suicide ideation and behavior measures. We had a survey process that went prospectively where we reached out to folks every 2 weeks over the course of 1 year after their initial enrollment. We downloaded their search data, or they did, or it was a big mess, but we'll talk you through what was happening in trying to get this data at the baseline and have been analyzing the data at the baseline and then collecting the data also prospectively throughout the year. Our goal was to have a group of 500 folks who had attempted in the past year, 250 who attempted but over a year ago, and 250 who had not attempted. This was a bar that we did not reach, but we'll tell you how far we got. So to enter the study, the individual had to speak and read English, be 18 and older, be living at the moment in the United States, have at least one Google Gmail account, which means that it comes with your Gmail email. that is not managed by employer or school, so that it was representing your own search data, and we didn't run into any issues with your employers. That they had current suicidal ideation. They were willing to provide information about their suicidal ideation and behavior. They're willing to share their Google data, and they consented, and they were able to show they had Google search data, at least one search per week over at least half the weeks of the past year, which is really actually quite a low bar. But we really wanted to have some kind of floor in the amount of search that would make somebody eligible for the study, but still allow a fair amount of variation. So the procedures that we used, the patients were recruited from different online sources, including Mental Health America, Research Match, AFSP, etc. And they came in through a website that told them a little about the study. And if they were interested, they entered our REDCap study survey system, which took them through a pre-screening, consent, screening items, a baseline survey, then, depending, and we'll talk about this at the order, they completed a data donation. We did some data checks to prevent fraud. Then they did their Zoom interview, and then we followed them out for a year, as I said. We started the study with fraud prevention strategies that had been developed by the Creative Lab, and then we expanded it as the timing of the beginning of our study was when there was nationally a big uptick in fraud on online studies. And so we really had to respond to the changing environment around us. Participants were compensated in Amazon gift codes for completing the study procedures. So this is a quick eyeball of the different assessments that we used, kind of demographics and service utilization, a range of retrospective and prospective suicide measures. We looked at a number of warning signs for suicide attempts, and Kevin will talk about this more later. We collected search and YouTube data, although at this point we're only analyzing the search for this presentation today. And we used the University of Washington Revised Risk Assessment Protocol, which we revised into an online as well as interview versions to manage the risk of our suicidal participants. So we went through a lot of changes, 12 essentially procedure changes to be able to try to find the optimal recruitment strategies. Peyton will be putting a PDF in the chat that has kind of detail on this. I'm just going to blow through it very quickly. So we started with the initial procedures, as I just said. First thing that we decided to do to try to improve participation was to switch do the data donation first, and see if people didn't have the data to donate, then we didn't need to be bothering them with a whole baseline survey, etc. Then we removed some screening items that didn't actually make sense in the context of the study. Kind of might be limiting people by limiting what search browsers and engine items they were using. We then kind of realized that we better deal with the fraud issue by not giving people money early in the process, because then we could potentially blow our budget on people who actually can't enroll in the study. And so we moved payment to the end of the study. Then we tried having data donations with staff. We'll talk quite a bit about where we ran into problems getting the data to be donated. So then we had one-on-one appointments to have them donate this with the staff, but they weren't always showing for those appointments. So we switched to a drop-in version, and then nobody came. And so we then moved to giving them an option of either drop-in or doing it on their own. And we still were not getting where we needed to go. So we made a big change, moved the baseline survey right after screening and merged the data donation and the interview together so that they could do the data donation with the interviewer, make sure they got through all the steps correctly. Um, and then we changed the amounts that we paid people to participate in the study to increase enrollment. And then we shortened the interview to make the study less burdensome for people to participate in. Um, and that was our kind of best model. But we were concerned that we did not have enough folks with a past attempt. So we first changed screening criteria to past year attempt only to increase that group, and then didn't have enough people, and so changed it to lifetime attempt only, and that's where we stayed until the end of um, the study. And I'm going to hand it to you to tell us about the lessons learned.
Yes, let me reshare my screen if it will work. Come on. There you go. Okay, you guys seeing this? Beautiful. Yes. Okay, awesome. So my name is Peyton Smythe. I'm a research scientist at CSPAR, and I worked on this study. I'm going to talk about some of our lessons that we learned. We learned a lot of things. Um, so the first lesson we learned was that there is so much fraud in online research. We noticed right away that the different recruitment sources we were using brought in different rates of fraudulent actors. So we had an advertisement on Mental Health America's website, and that was kind of our most reliable recruitment source. We got the most people from there, and they also had not as much fraud. We also used Research Match, which is NIH's own recruitment service, and that ended up giving us a lot of issues with fraud to the point where we had to shut it down and then exclude anyone that said they found our study through Research Match after we took it off. We also posted a few social media advertisements in the beginning of our study, which ended up giving us a lot of trouble and introducing us to the problem of fraud. However, I do want to mention that another CSPAR study, the COVE study, which did a research spotlight in, I believe that was May, they had success recruiting from social media with minimal fraud. So I think it's just about how you kind of do it. So it's a mixed bag, in my opinion. An important lesson that we learned is that we have to use many different fraud prevention strategies to keep our study running with as minimal fraud as possible, and that these strategies also take a significant amount of staff time as well, which is important for planning things like grants and FTE for online studies specifically. So to begin this process, our team had to define what behavior we considered to be fraudulent. So we used this wonderful article by Wang and colleagues to help give us some ideas of how to define this. This boiled down to two different types of indicators. So fraudulent indicators, which is like a one and done, you are considered fraudulent if you do this, and suspicious indicators, which is something that is not necessarily enough to rule someone out by themselves, but in combination with other things could rule someone out. So things we considered to be fraudulent were having different locations in different fields that were measuring location. So we had a device timestamp, city, state, and zip code. So if any of those were different from each other. We also had many different people enroll multiple times using the same contact information with significantly different responses in each record, which was considered fraudulent. And then our last indicator was if someone donated Google search data from a fresh account created just for the study. And then for suspicious indicators, some examples were using a VPN during the interview, reporting self-injury history on our survey, and then having none on the interview, and issues with confirming contact information during the interview. So we used a mixture of automated strategies and strategies led by staff to find fraudulent actors. The automated strategies were helpful. This included having a field in REDCap that recorded the participant's device timestamp and automatically screening them out if their timestamp was said that they were outside of the United States. And then once we stopped using Research Match as a recruitment source, we had an item at the beginning of our survey that asked where participants came from. And if they said Research Match, they were automatically screened out. We also set up Zoom and our application for data donations to block people outside of the United States and Canada from joining and donating their data. Um, So those were our automated strategies. And then for staff-led strategies, I think the most important thing that we did was having language for our IRB protocol and consent forms that specified that fraudulent participants would not be paid and would be removed from the study, which set a precedent for us. And most of our fraud was found by study staff comparing survey responses to other records responses or comparing interview responses to survey responses that were like significantly different. Um, I also wanted to list some helpful fraud prevention articles. So this slide is for the people who are watching on YouTube in the future. They can take a screenshot, but I also have a PDF of these that I will go ahead and put in the chat once I'm done. These are very helpful. Like there's kind of a growing literature in this area. But it's helpful to see what other research teams have done. And then if you're doing an online study in the future, you can read these and see what they did and figure out what works for your study team. So now we're going to talk about our second lesson, which was participant attrition. We had a little over 15,000 people enter our pre-screening survey to join the study, but throughout our enrollment process, we lost so many people and ended up only enrolling 485 people due to the nature of our study flow, which is about 3% of that 15,120 number. We ended up classifying that 63% of our sample were lost at some point during the enrollment process, so they just completely vanished on us. We have a few reasons that we think that is. We didn't specify everything about the study in our advertisements to avoid fraud. So we think a lot of people who reached the consent form and did not complete it and just left. We think that's because they found out more details about the study and, either weren't comfortable donating their Google data or didn't want to do an interview, things like that. We also had people get lost at the data donation step, which I'm going to touch on more in our next slides. And for our interviews, we also had a lot of people completely ghost us and just no-show us, which seems to be common among other studies and in like some clinical practices. So when we would go out of our way to kind of find these people, track them down, and then reschedule them again, something that I thought was interesting is that they very rarely showed up for their second appointment. So if they scheduled another one, they very rarely showed up. And I always was happy to reschedule people, especially if people like something important came up and they couldn't make it. But it usually didn't pay off for us, which is interesting. Um, but we do have good news. So for our 485 participants that enrolled in our study, we always had at least a 70% completion rate at every time point in follow-up. As you can see on the figure on the right, we finished our last time point off very strong with 86% of our participants completing their final survey and 72% completing their final data donation. So it's all not all bad. So here are some strategies to kind of decrease attrition that we tried. We set up our survey and interview systems to send out reminders to participants to complete their surveys and to show up to their interviews. Want to shout out Amanda and Michelle for making this possible because they did all the red cap magic. We also did manual reach outs for interviews if they did not show up like 5 minutes after their interview time. We also, another thing that Kate previously mentioned is increasing our gift card amount to get people to be more likely to show up for their interview. So I think that did help, in my opinion. And since data donations were hard, we gave people the opportunity to do their data donation over Zoom with a study team member in both baseline and follow-up. So now we're going to talk about data donations. Our third lesson is about how difficult they were. So first off, we were using Google Takeout, which is Google's own data download service. I recommend checking it out if you're curious. Anyone can download their own data. We were limited to using this interface only and had no control over updates or bugs that they had. So I've added a few screenshots to show you what this process is like. So as you can see on this first picture right here in the right-hand corner, there are 70 different types of data that you can download from your Google account. And our study needed a very specific one, which is my activity. So participants would have to make sure that all of the other ones were deselected and that my activity was selected. Then they would have to change the format of that data, which is another button click and another place where this can go wrong. And then they have to select which specific data they want from their My Activity. And we only wanted search and YouTube data. YouTube was optional, but most folks gave it. So they would have to make sure that those were selected and that the rest were deselected. So obviously, it's a lot of button clicks. And lastly, they had to change where the data would be sent to. So it wasn't automatically set up to send where we wanted it to go, which was their Google Drive. So if they clicked the wrong one, it wouldn't go to the right place and it would give us an error. So very limiting for us. We couldn't control exactly what Google Takeout offered. Um, to try and help with this process, we developed our own application, which we call GTAP. This is what GTAP looks like. Participants love this little dog GIF on the end, so I wanted to include it. GTAP made this process more secure than, say, like having participants email their takeout data to us. But we ended up encountering many different difficulties, the majority being errors that were either user errors or tech errors. And then about a third of the time when participants were able to actually get their data donated to us, their account would not have enough data to be eligible for a study with the bar that Kate described earlier. There is a setting in Google that changes how often your search data is deleted from your account, which I had no idea existed before working on this study. But this caused a lot of people to be ineligible, and often they did not even know that they had the setting on to delete all of their data or to only retain the past 3 months of their data. And sadly, both GTAP and Google Takeout broke multiple times throughout the study, which always kept us on our toes. Something was always happening. So keep things interesting. We gotta love it. To improve data donations, as Kate showed earlier, we added the data donation at the beginning of the baseline interview and had our study team member walk them through. This helped us to get way more people through the process because they were motivated to attend the interview to get money. Well, not necessarily. That's not the only reason why they're motivated, but adding it to the beginning of the interview got us the most people. And it was very helpful for us because we were able to see errors as they happen and then address them right there. We also made appointments available to anyone who wanted to do a follow-up data donation with the study team member. And we provided instructions in video form, written form, FAQ form, you name it, we probably tried it. And then for anyone entering follow-up, we let them know that if they had any issues at all, they should schedule, they can not schedule, they can email us, schedule an appointment, and we're happy to help. And then near the end of the study, Google released a policy that made our application no longer usable, which meant we had to create another way for participants to get us their data. So we ended up having participants securely upload their takeout file through REDCap, which is secure and locked down, which worked well and is about the same amount of labor as GTAP. I have a tiny bonus lesson that I'll do really fast. So since this is CSPAR's first ever online study, Amanda helped develop our online risk management procedures based off of the University of Washington Risk Assessment Protocol, known as the UREP. And since the study was not offering treatment, we used online mental health resources to send to participants. So if participants were flagged with suicide risk, we would show them crisis and mental health resources on their survey screen and send them by text or email if they'd like. We also created a resource plan and added that to our interview, where the interview and participant co-created a plan and talked through resource options. And then on our last study survey, we asked participants about if they like this approach, and most participants ended up liking it, and 45% said that they used the resource provided by the study, which is awesome. So those are all of our lessons. That's it from me. I will pass it over to Shinyong. Thank you so much.
Yeah, thank you. My screen. Okay. Hi everyone. Thanks for attending. I'm Xin Yang a fifth-year PhD student in biomedical informatics. I'll present our work applying anomaly detection methods to various preceding suicide attempts. Suicide is one of the leading causes of death globally. Computational methods identify individuals at risk. Commonly utilized. However,
Hey, Xingyang, you're
these
freezing.
data sources.
So hang on, you're freezing. Could we try it without your video?
Can you hear me now?
Yeah, I'm hearing you now.
Uh,
No, you
uh,
think you're cutting back out
and
again. Try it again.
can you hear me?
Yeah, That's better.
Okay, thanks. However, these data sources have several limitations in identifying proximal suicide risk. One key disadvantage.
Oops, it cut out again.
Okay. Um. Sorry about that. I'll try to not use the um. Sorry about that. I'll reshare the screen again.
Okay.
Um. Can you hear me?
Yep.
Okay. Um. Okay. However, these data sources have several limitations in identifying proximal suicide risk. One key disadvantage of social media data is the image constructed through one's online identity, which may be curated, inauthentic, or distorted. Moreover, social media data are age biased, with a skew toward younger generations. EHR datasets are generated at points of contact with the healthcare system. However, the rate of mental health service utilization among individuals at risk remains low, at less than 30% for those experiencing suicidal ideation. Personal web search queries are a largely underexplored data source for proximal suicide risk detection, and it has several advantages. Approximately 94% of Americans use the internet, so there's high rate of internet usage, and search queries are captured incidentally as part of day-to-day activities. In this work, we hypothesized that personal web search queries showing one's real-time and real-world behavior can reveal dynamic and state-based suicidal risk factors. We utilized 111 reported attempt records from the GTO data from both retrospective and prospective periods. The attempts have different temporal certainty levels, and we focus more on those attempts that are at exact temporal certainty. These attempts belonged to 80 participants in the study, and here are the demographic information. You can see that they are mostly young, women, and white. As web search query data are voluminous, and most queries, even for an individual at high risk, are unlikely to be suicide-related, we developed neural language representation techniques to calculate a proximity score between each search query and suicide-related constructs. We then apply standardization to calculate the z-scores based on all the participants' search history. After that, we applied a conservative z-score threshold, empirically determined in the pilot study, which is 3.5, to the standardized proximity scores to select construct query pairs that have meaningful similarity in the semantic space. Moreover, we further utilized the up-to-date large language model, Llama 3.1, developed by Meta to adjudicate whether the search query is relevant to the constructs. Here you can see an example query called overtired can't sleep, and the process that we decide that is relevant to the construct sleep problems. Besides semantic features, we also constructed behavioral features, including total number of searches on a given date and the percentage of searches within the 6 4-hour time frames. Here's an example of searches related to constructs extracted from a participant of web search history. All the web searches related to different constructs are highlighted in different colors, and the red vertical line indicates the suicide attempts. As you can see, in the time periods proximal to the attempts, there are few searches highly relevant to different constructs, including interpersonal problem, suicide communication, alcohol, anxiety, burden, etc. Anomaly detection is the process of identifying data points or patterns that significantly deviate from the majority. We applied anomaly detection methods to discover abnormal suicide-related search behaviors preceding the attempts, and we compared two different training approaches. One is the individualized approach, where the model was trained and tested on data belonging to a single participant. The other is a generalized approach, where the model was first trained on data from all participants and then evaluated individually. We used approximately 6 months data preceding and including the suicide attempt date as the test data, and we defined the 14-day preceding the attempt including the attempt date as the attempt period, showing as the black block in the figure. And all the other 14-day periods in the test data are referred to as control periods. We use all the data more than 6 months before the test data as the training data. So the goal was to successfully distinguish attempt period from the control periods in the test data. We use up-to-date software framework called TODS to evaluate different anomaly detection algorithms on the research problems. Besides that, we also implemented the placement value methods proposed in the pilot study. To evaluate how effectively the anomaly detection model distinguished the attempt period from control periods, the ROC-AUC scores were calculated. A higher value reflects greater success in detecting proximal suicide attempts. Here are the results. It shows the median ROC-AUC scores across attempts for the proposed methods. The best performing ones were the autoregressive based outlier detector. The majority of the attempts can be effectively distinguished from non-attempt periods, with a median ROC-AUC of up to 0.75 across attempts. The impact of temporal certainty in suicide attempts on the detection performance can be observed. The more precise the attempt timing information is, the more accurate the detection model estimates appear to be. The individualized training approach improved detection performance and outperformed the generalized approach. The box plots here demonstrates the distribution of model performance trained on a combination of semantic and behavioral features, or on a single feature type only for attempts with precisely non-timing. You can see here for the retrospective attempts, behavioral features alone provided limited information for risk detection, the orange block here, and the semantic features taking search content into account and reflecting similarity to suicide-related constructs were beneficial for detecting suicide risk. The findings are similar for the prospective attempts. So these results suggest that individualized models for suicide risk detection using semantic and behavioral features extracted from search logs may be of value as ways to detect periods of heightened suicide risk. Thank you for listening.
Thank you so much, Yang. Now we'll move to Kevin to talk a little bit about the data we collected through our prospective surveys.
Hi, everybody. Thanks for having me. I apologize in advance. I'm getting over a cold, so my voice might sound a little hoarse, but I appreciate you bearing with me. So today I'll just talk about some of our findings looking at the prospective data from this sample. I have nothing to disclose. These are my own, not those of the funder or various employment agencies. Most research, I guess, to set the stage for this investigation, most research in the field of suicidality has focused on trait-like risk factors that differentiate between individuals at high risk for suicide versus those at lower risk for suicide. And this work is helpful for identifying those who are at elevated risk, but just little to identify when they might be at most risk. And to identify these high risk periods, which are really periods that are important for intervening to prevent suicide, we need to understand when individuals are at most risk. And that is where understanding suicide warning signs comes in. And suicide warning signs are markers of heightened risk for suicidal behavior in the short term, whether that's minutes, hours, or days. By definition, they must fluctuate with individuals and directly precede suicidal behavior. These warning signs are typically examined using case crossover methods, in which a time period in an individual that had the event of interest, say a suicide attempt, is compared to a time within that same individual where they did not make a suicide attempt, and kind of teasing apart what's difference between the periods where the suicide attempt occurred and did not occur. And so these methods are really helpful for identifying kind of differences between times where kind of individuals made suicide attempts but did not. However, they are unable to identify prospective associations, with between these constructs and suicidal behavior. And potentially as a result, the warning signs that have been identified by case crossover methods previously have mixed findings regarding those that are most associated with suicidal behavior. And so research is really needed to understand prospective associations between these risk factors and suicidal thoughts and non-fatal suicide attempts, abbreviated as SI and NFSAs um, for ease from here on out. And so participants were from the GTO study. The outcomes that we were interested in were suicidal ideation, captured by the Beck scale for suicidal ideation, and non-fatal suicide attempts, captured by the SITB interview. The warning signs were single item measures of emptiness, hostility, scared, burdensomeness, interpersonal negative life events, insomnia symptoms, alcohol use quantity, and drug use, capturing independent cannabis, depressant, and stimulant use. And so we used hierarchical linear and logistic regression models to examine these outcomes. We looked at both the associations between the warning signs and suicidal ideation and behavior at the same time period, as well as the warning signs at the previous time period, predicting next time period outcomes. All analyses controlled for age checks and suicide attempt history, and the prospective models additionally controlled for the presence of prior time point suicidal ideation. So descriptively, there were 465 participants who completed at least one follow-up survey. And just in the interest of time, I won't go over all of this, but 99.8% of the sample reported suicidal ideation on at least one occasion, and 57 individuals reported at least one suicide attempt over the course of the study. The demographics, the sample was predominantly female, white, non-Hispanic. And so these are results from the kind of cross-sectional models, concurrent associations between the warning signs and suicidal ideation, with those cells that are highlighted in darker orange being those that were statistically significant. And so we found, again, in this multivariable adjusted model that interpersonal negative life events, emptiness, hostility, scared, burdensomeness, insomnia symptoms, and depressant use were all positively significantly associated with concurrent suicidal ideation. In our model then of prospective associations, we found a somewhat smaller subset of those warning signs that were prospectively associated with suicidal ideation. Again, controlling for prior time point ideation and some demographic covariates, with emptiness, uh, perceived burdensomeness being the sense that an individual feels like they're a burden to others in their lives, and alcohol quantity being prospectively associated with future thoughts of suicide. Now for non-fatal suicide attempts. Here we found that the majority of the warning signs were concurrently associated um, with suicide attempts, with interpersonal negative life events, emptiness, scared, burdensomeness, and depressant use being associated with increased risk, with hostility, insomnia symptoms, cannabis use, and stimulant use being associated with decreased risk. And some of these were unexpected and not necessarily in line with prior research, particularly findings related to hostility, insomnia symptoms, and stimulant use, and have some potential thoughts on why that might be, but I won't go too much into detail for the sake of time. And then for prospective associations, we found that the presence of interpersonal negative life events, the feelings of emptiness, hostility, and stimulant use were all associated with increased risk for non-fatal suicide attempts at the next time point. And so in conclusion, we found that warning signs were concurrently and prospectively associated with suicidal ideation and suicide attempts. With across all of the models, emptiness was the only warning sign that was consistently associated with outcomes. I think these findings really highlight constructs to consider when assessing prospective suicide risk. Some of the limitations, the 2-week follow-up period for constructs that are thought to increase kind of acute proximal risk for suicide might not necessarily be some of these risk factors might operate on kind of a shorter time scale. And so that might be one of the reasons why we did not see significant associations looking across a longer time period. That's the main thing I'll highlight. And yes, so happy to acknowledge co-authors, funder, and open it up for our discussion.
Great, thank you. It's really lovely to see all of the data from a study that was really complicated to pull off, and really appreciate being invited to come and serve as a discussant. What I'd like to do is mostly take questions from the audience, but I do have a few overview, comments to make based on what I heard today. I think one of the things that's really important is to think about the context in which the study could be helpful. Historically, there's been a really strong interest from NIMH, even the National Institute of Nursing Research, and the National Association for Science, Engineering, and Medicine on using this kind of data to predict or at least understand in a population level what the risk factors are for suicide and whether or not there are ways to intervene early. Understanding time, the time variation of suicide risk and whether or not there are critical periods there where we could intervene. I think it was in the summer of 2023, NASM had hosted a workshop. I encourage you all to take a look at the recommendations. One of the challenges or one of the goals that the workshop originally had was whether or not was to bring tech companies who have been sort of on the forefront of analyzing their own data to determine whether or not they can predict suicide risk or other types of harm to the population, and to see if they could bring them to the table to be more collaborative, to share their databases and their strategies for being able to identify risk. This did not happen, obviously, because these companies have proprietary interest in not sharing their data or sharing only aspects of the data, but not the entire database that they would be using for these prediction models. I also companies, while early on, companies like Facebook, even Google under Google Health or Verily, one of the smaller companies, was very interested in using search data to predict suicide. Eventually, they came to the conclusion that they are not health companies, although Google Health technically is. And so therefore, they were not willing or interested anymore in creating, ways to proactively identify suicide risk and then providing intervention. The messaging changes every year. However, I think the strength of the interest in this area from the tech company's perspective has not been super strong. That means it's on us as scientists and healthcare providers and advocates to figure out how do we conduct this research so that we and figure out whether or not this information is useful. Should this be something we pursue down the road, or is it no better than any other data sources that we may have in order to predict population level suicide risk? So it kind of reminds me, the tech companies' response to whether or not they should do this reminds me of the early days of mental health integration into primary care medicine. This was something I was involved in very early in my career, where you would talk to primary care clinicians or organizations, and they would say, well, sure, older people tend to take their life, but is that necessarily our responsibility? Shouldn't psychiatry be doing this sort of work? Why do we have to do it? Asking about suicide would open up a Pandora's box that we would not be able to address. And as you can see, after decades of research showing that, there are models to, detect and quickly intervene on conditions like depression, anxiety, and so forth, that we do have integrated care models that are supported by health plans. So it's not a done deal when a company says, this is not our business. At some point, there's a way to kind of show through scientific method that, you can actually do this. And you can do it responsibly, without incurring a risk of doing something that you were not technically set up, to do as your primary business model. So that's sort of the contextual comments I have about this work that is very important, and I think we should continue doing it, particularly based on the pilot data that supported the R01, as well as the data that we heard about here. I think that, some of the challenges around collecting the data, recruiting, participants who are not in it for some other, issue that it, or who say they are someone that they're not, I think can be worked around. We can develop standards for conducting this type of research that would mitigate, having to deal with fraudulent acting. I noticed in the chat, Mark had asked, how many fraudulent actors did you detect? And it was 3% of the sample. However, that's about 500 people, and it's a lot of people to screen out and a lot of effort. So I think it's important to continue thinking about, as methodologists, what could we be doing better? What standards could we create in order to allow us to do large-scale population studies in this manner? Maybe combining, platform, social platform recruitment with, local recruitment to see, whether or not we can enhance the signal from this kind of data. In terms of the outcomes of the study, I had a few questions I wasn't clear about. So one is that it does sound like semantic behavioral signals can predict future suicidal behavior, and that there are certain semantic features that seem to have more weight than others. But one thing I wasn't clear about is in the pilot study, we were able to detect certain timeframes when you might be most successful or when the signal is strongest. And so if I recollect correctly, I believe the pilot study had found that, there was like a 3-month window where you could potentially start to see risk, predict risk. And it was all the same as what we're finding here, was really individual models. It wasn't like a group generalized model that seemed to be predictive. And that the signal got stronger the closer you got to the event. So I'm curious as to what timeframes we're talking about, both in Kevin and Xiang's analyses. So I'll start off with the question.
Yeah, thanks for the question. So for our analysis, we mainly look at the 2-week window. We initially tried the same time window as in the pilot study, 7, 15, 30, and 60 days. And then we focus on the 2-week window for all the analysis.
Okay, so I mean, 2 weeks is still better than, I don't know when they're going to take. They might attempt. So there's still a window. It's a short one, but a window of opportunity to intervene. It's just, it sounds like it's not as broad as we originally thought from the pilot.
I'm not sure we can say that. So what Xinjiang did was compare 2-week windows to each
I
other.
see.
I
Okay.
think over a 6-month period preceding the event. So, with some attempts, the 2-week window that preceded the attempt would be ranked as much higher risk than the other windows in that, I think it was a 6-month period, right? But
Yeah.
with other attempts, they weren't ranked higher. On average, they were, right? But like some were more detectable than others. And if somebody had shown signs like 3 months before, and then those signs had dwindled, closer to the attempt, with our evaluation, it would look like the model was unable to detect them. But there may well have been some indication earlier.
Okay.
It just wouldn't show up in the way that we've run the evaluation here. It would actually look as though it hurts performance, because we were looking for proximal indicators.
I see.
So you can even see in that diagram, right? Like if you look at the figure that Xinjiang posted of the searches, like you could see searches that were lighting up well before the attempts as well. And that may reflect that some people have a pattern of behavior where they're just constantly searching for content related for the constructs, which would make it really difficult to detect periods of acuity. Whereas other individuals may show, warning signs in their behavior much closer to the attempt itself.
Okay. And that plays into the fact that, there isn't going to be one algorithm that's going to be useful for everyone, that's likely each individual has their own patterns of potential prediction. Is that right?
Yeah, and I think some people would just be easier to detect this way. So, I mean, of course, like we've started looking into this of people who search more frequently, people who actually do search for things that are related to the constructs that we've laid out, are the people we can detect periods of risk. But, not everyone behaves that way. So.
Other questions in the last 5 minutes from the audience? You can either put it in the chat or you can raise your hand and ask. Mark?
Hey there. So I guess I'd be interested. You started with such a powerful description of the challenges of this kind of research. I'm wondering if you recommend that people do this kind of work given our tools that are currently available. And secondly, for those primary analysis, I'm having trouble understanding exactly what you found too, but maybe that's for a follow-on time. But is the quality of the data that you had available for those final analyses such that you feel like we can rely on them, or is this really turned into more piloty hypothesis forming data?
So Xingyang, Trevor, and Kevin may want to answer that question about the quality of the data, and I'll talk about the methods later.
mean, I think the quality of the data, I don't know, it's like as good as we could get from people's Google search. Like it's very rich data. And it's data that you know sometimes people will donate, will have years of data leading back. And I do think we see signal in it. I mean, I think the open questions are like with the degree of um, accuracy that we're able to predict things, you know, like what would a meaningful next step be if we wanted to try to use this in the context of care, right? Like say we, after Pat's, you know, comment there about search companies, like I don't know that we can actually expect collaboration, but you could imagine a model where you have something like this living in a browser. You don't really need permission from Google, like the data are being analyzed as they come in. And then, you know, the model would flag some content as potentially risky, but like with some degree of error, right? Like in the flagging and with some degree of error in as to whether this is actually going to anticipate an attempt. But you know, it's still, I think, useful information. And like the question of what to do with it is still an open question. Like, what would the next step be? So when I think about this, like I think it's the sort of thing that would have to happen, you know, with a person's engagement and consent. Like they might be in a relationship with a care provider or in some sort of caring contact type program where they'd given permission for signal that comes out of their search behavior, even if the actual search is not communicated, you know, for some sort of ping to go somewhere to someone who would then reach out to offer help. But, you know, I think a lot of those details are yet to be worked out. And, you know, they all have to be thought through, bearing in mind that it's not a perfect, you know, predictor that we have. So, you know, yeah.
I think a good example of something like that where, it's not going to tell you when, but it's useful to determine who might be at risk is like the Reach Vet program in the VA, which apparently I don't know about if this is true because I've heard this third hand, but it's one of the few programs in the VA that the vets don't complain about, right? And so and so knowing that this is just a you may be at risk kind of algorithm, they still intervene because of the VA still intervenes because of the potential, adverse, how adverse the event would be if you didn't. And so some people may not be feeling like they're about to take their life, but they're certainly in distress and appreciate getting a call from a care manager who's like, hey, I'm checking in on you, much like in a caring context kind of way. And so, something like that could be, you could envision something like that being in like a health plan. I mean, or in a school system or something like that. We'd have to think about the different avenues. I mean, one of the things that Kate had written in the grant proposal that I thought was really compelling was that there's an opportunity to do some sort of surveillance and identify people who aren't connected to a mental health system. And that part will be really challenging. Like, how do you do this? And it might still be on a volunteer basis, or it might be triggered by, for a while, I don't know if Google does this anymore, if you had search terms that might alert that you may be depressed or not feeling well, you can take the PHQ. Yeah. Now in our surveys of participants or people who have, when we've asked them, did you see that? Most of them didn't. So it wasn't exactly, or didn't fill it out. So there are some challenges there. But, based on some of the survey data we've done around this project, which I imagine, Kate, you might be wanting to present in a future CSPAR meeting, there was some interesting ideas about, what would intervention look like? What would be the concerns people would have about any kind of surveillance type of algorithm, particularly if they're the type of person who just searches this information, regardless of whether they're feeling sick or not, or feeling like they're in distress or not. And like, please don't intervene just because I've been looking for ways to, I see searching information about suicide. So So we're a minute over. I don't know if there were any other questions. This was a really rich discussion. The study is super cool, and I imagine there's a lot more data that could be analyzed and looked at. So there's a really rich database that we have that you all have access to. So I will end it here. Thank you very much, everybody. Nice to see you
Thank
all
you very much.
Thank
There's
you.
an evaluation